Imagine that a book is placed on a table and it does not fall down because it is supported by the table. We know that contact objects exert force to each other because of their weights. Owing to this reason, the book exerts a force to table because of its weight, and table also exerts force to the book. In general, a direction which is perpendicular to the plane of a surface is said to be normal. Note: the attractive force between any two massive objects is called gravitational force. The force that a solid surface exerts on any object in the normal direction is called the normal force. In the above example, the downward gravitational force is being balanced by the upward normal force. Since these two forces are of equal magnitude and acting in opposite directions, the sum of these forces, that is the net force acting on the book, is zero, and the book is said to be in equilibrium. Imagine that a stone is suspended with the help of a thread or string and its free end is tied to the retort stand. We know that the stone would fall down due to gravitational pull or weight of the earth if the string is broken. For a stone tied to the thread, gravity pulls down the stone all the time, but it does not fall down because it is supported by the thread. Thus, there exists a force which supports the stone against gravity by pulling it upward. It is called tension, which always pulls the bodies along the string. The direction of the tension force is always away from the surface of the object to which the thread is attached. When we try to stretch a thread or a string, the tightness of the thread or string is called tension. In the above example, the gravitational force is balanced by the upward tension force. Now, let us do a lab activity to find out the limiting force that can be bared by a string. Click each tab to know more. The aim of this activity is to find the limiting force that a string can bear. The materials used in this lab activity are spring balance, weights, light strings, weight hanger. Arrange the system as shown on the screen. Put some small weights like 50 grams on the weight hanger. Observe the readings of the spring balance and note down. Now, add some more weights to the hanger. Once again, note the readings of the spring balance. Repeat the same process till the string is broken. Note the reading of the balance when the string is broken. Separate the whole system from the ceiling. Now take another string and tie its one end to weight hanger and other end to the spring balance. Place some weights like 50 grams. Now slowly pull up the whole system with your hand. Note the readings. Repeat the same procedure for various weights like 100 grams, 300 grams, and 500 grams. In this activity, we observe that the force required to move the weight hanger over the surface increases with the increase in the mass of the weight hanger. Finally, we learn that the frictional force which opposes movement must also increase with the increase in the mass of moving object. The limiting force that a string can bear is the maximum load that we can hang from it without breaking it. The maximum tension with a string can bear is called its breaking strength, which depends upon applied force and material of the string. Now, let us perform an activity to understand the magnetic force. Click each tab to know more. Take 2 sewing needles. Take a bar magnet. Rub them in the same direction with a bar magnet several times individually. Now, the needles act like a magnet. Now take a compass. Identify the north and south poles of the 2 needles. Similarly, identify the south pole of the needles. Take a white color foam ball and pin it to the north pole of the needles. Take a red color foam ball and pin it to the south pole of the needles. Now take water in a bowl. Drop the needles in a bowl of water side by side so that their like ends with red or white balls face each other. Observe the changes. Now take them out. Once again, place the needles in such a way that unlike ends, one white ball and one red ball of each needle faces each other. Observe the changes. In this activity, we observe that the red end of one needle and white end of another needle attracts each other and that the ends with same color repel. Finally, we learned that the like poles repel or push each other and unlike poles attract or pull each other. This action of pull or push results due to a magnetic force. A magnet can attract or repel another magnet without contact with that magnet. Now, let us perform an activity to understand the electrostatic force. Click each tab to know more. Take a balloon, inflate it. Now tie up the open end with the help of a thread. Take a white paper, cut it into small pieces. Place the small paper pieces on the table. Take a balloon and rub it with another paper. Now bring the balloon near the pieces of paper. Observe the changes. In this activity, we observe that there is an attraction between the balloon and the paper bits even though the balloon is some distance away. Finally, we say that when the balloon is rubbed with a paper, it acquires an electrostatic charge on its surface. The balloon is now said to be a charged body. When it is brought near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. It is an example of a force at a distance. We observe that a ball kicked upwards always comes down to the ground. Similarly, a fruit detached from the plant falls on the ground. This is because earth pulls them downwards. This pull of the earth is due to a force called gravity. When we lift a dumbbell, we apply a force upwards against the pull of the gravity. Similarly, if an object is thrown upwards, there exists a force which pulls it down towards the earth. Because of this, it falls down on the ground. We call this force as gravitational force. Every object on the earth or close to earth will experience a gravitational pull. The force of gravity is not just due to the attraction of the earth. It is a force of attraction that exists between any two bodies or masses everywhere in the universe. The earth is so massive and huge that all the other objects close to the earth are attracted or pulled towards it. The force which acts between two bodies when the bodies are not directly touching each other is called force at a distance. These forces can be explained by using the concept of a field.